Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the full wave rectifier. So you can see that this is an arrangement which produces a full wave rectification of AC input, and this is also called as center tapping rectifier because we have tapped this wire at the center of the secondary coil. So I'll tell you the significance of this thing. So first of all, let us discuss the fact that this is input AC voltage, and first of all, let us discuss its functioning. That when positive half cycle occurs, then this terminal is negative, this is positive, this is negative, this is positive, and due to mutual induction, a phase change of 180 degree occurs. So this will be plus, this will be minus, and this diode will be in forward bias and this will be in reverse bias. So the current will be flowing through this diode like that, and the current flowing through the load resistance will be like that, and the terminal A will be positive and terminal B will be negative, and output voltage is VA minus VB. So you can extract the output voltage like that. And when the negative half cycle occurs, so in the negative half cycle, this becomes positive, this becomes negative, and again this becomes positive, this becomes negative. So this is negative again and this is positive. Now this is reverse biased and this is forward biased, and the current flowing through this diode is like that again. So again, current through the load resistance is flowing in the direction from A to B. So again, A will be at the positive terminal and B will be at the negative terminal. So a DC will be produced like that. So this is a full wave rectifier, because you can see that for complete wave, for complete cycle of the input, output is received. So this is full wave rectification. Now you can see that if the frequency of input is f, so which means that it is repeating itself after or we can say the time period after t time. So 1 upon t will be the frequency. So the frequency of output will be equal to 2f, and it is due to the fact that it is repeating itself in half time. So output is repeating itself in t by 2, while input is repeating itself in time t. So the time period of output is half of the time period of the input. Therefore the frequency of output will be double of frequency of the input. This is first difference between the half wave rectifier, in which frequency was same of input and output, and in this full wave rectifier the frequency is double. Frequency of output is doubled as compared to the frequency of input. Now let us talk about the average output of the full wave rectifier. So if we talk about the thing, that if we say that if this voltage is Vm, or we can say that if this is V0, V0 is the input voltage, this is V input, will be equal to V0 sine omega t. So this voltage will be, this one will be V0 by 2. Because the voltage at this point, if voltage at this point is 0 and voltage at this point is V0, then voltage at this point will be V0 by 2. This is V0, this is V0 by 2, and this is 0. So what I am trying to say is the fact that the potential difference across the half coil of the transformer, secondary coil, is only V0 by 2. Okay, and therefore we can say that the current flowing in this case, or if we talk about the V of secondary coil, then it would be Vm by 2, in fact V input by 2. So V input by 2 will be V0 by 2 sine omega t. So this is the voltage of secondary coil which is provided to the diode and load resistance, and this voltage, if we talk about the average VDC, so VDC will be equal to V average and it would be equal to integration of V naught by 2 sine omega t, and the average of this will be easily limit from 0 to t, so it would be from 0 to t and divided by t. Okay, so you can see now it is very important to note that this is V naught sine omega t mod, okay, because it is always positive. This output voltage is always positive, so we have to put a mod here. So we can say that it is V naught by 2, and it is integration of sine omega t dt from 0 to t by 2 plus integration of sine omega t dt mod, and we know that this value will be negative in the cycle of t by 2 to t. So let us put a negative sign so that it becomes positive. Okay, so divided by total time t, because we have to use this value all over as positive. So integration of sine omega t will be equal to cos omega t minus cos omega t divided by omega 0 to t by 2, and obviously divided by t, and the integration of sine minus sine omega t will be plus cos omega t divided by omega, limit from t by 2 to t. Okay, so this is V naught by 2t, and the cos, if we substitute the value of t by 2 here, and omega is 2 pi by t, so cancelling 2 with 2 and this t with t, this will be cos pi, which is minus 1, and cos 0 is 1, so it would be plus 2 and plus 2 by omega, and this would be, if you will substitute the value of t here, you will see that it would be 2 by omega. So you can see that it is 4, in fact 2 V naught by t omega, and omega is 2 pi by t. So you can see that this is V naught by pi. So V average or VDC is V naught by pi for the full wave rectifier, and if we talk about the I average or IDC, so IDC will be equal to VDC upon RL plus R, where R, small r, is the resistance of diode. So we can also neglect this resistance, but right now we are not neglecting it. So V output DC will be equal to IDC into the load resistance, because we are referring the output voltage to the voltage across load. So the voltage developed across load will be IDC into RL. So V output DC will be equal to VDC into RL divided by RL plus R. This is the output voltage, and VDC we know is V naught by pi. So it would be V naught by pi into RL upon RL plus R. So this is V output DC. Okay, so this is the output voltage. Now if we talk about the ripple factor, and now the ripple factor of this full wave rectifier is 0.482, which was 1.21 for half wave rectifier. So ripple factor for half wave rectifier is better than the full wave rectifier. Now the efficiency of the full wave rectifier is double of the efficiency of the half wave rectifier. So this is the reason due to which full wave rectifier is preferred, and obviously it is filtering out the both cycles of the input into DC. So this is why we will prefer the full wave rectifier. Thank you.